First question, what is autonomous networking? You might have heard about something happening in California recently, wildfires in California. Firefighters have been active for weeks to secure the public from those fires. Their action has been coordinated through mobile broadband. Actually, as a matter of fact, this mobile broadband connection has been coordinated through a central vehicle, a command and dispatch center, which suffered from bandwidth throttling, having significant impact on the efficiency of the firefighters. This clearly is not autonomous networking. This is simply service level agreements reaching a volume threshold, and the service provider is throttling the bandwidth. However, what we would like to see is the network is intelligent enough to understand the impact of its action, to make decisions based on business, technical, yes, even ethical considerations, and decide that in this case, I will not throttle. The network has a known identity and decides with this identity with own objectives. That's autonomous networking. Clearly, we are pretty far away from that. The content of this presentation is to highlight what this future can bring us, but more importantly, to look at what action should be taken now to prepare, as well as what benefit short-term can we create when we follow this short-term action. This is our conclusion on what we need to do to prepare for autonomous networking. Left-hand side, that's a traditional network management system, proprietary hardware, monolithic solution due to proprietary interfaces, management system just managing the own network elements. That's the past. 3 areas where we want to innovate. Management. This comes from the Latin manus for hand and agere for taking action. We want to move away from that. We want to move towards machine-to-machine controlled solutions. This is what I represent here with a multi-technology SDN domain controller. Not the manual one, machine-to-machine activated control. This has various implications. For example, resilience of this solution needs to significantly improve. This piece now is service affecting. That's one thing. There's other considerations to be taken. One area is the evolution of the management towards control. But what value do you have from an automatic control if the underlying network is defined by hardware, limited to hardware functionality? This is why at the same time we need to move from purpose-built hardware appliances towards open software-driven solutions on the physical layer as well. NFV is progressing fast, but also open network operating system on top of white box switches need to complement. Probably in the future, we'll see general processing units being the basis with open software on top. So opening the hardware, the second piece, and on top of that, intelligence to create much more value from our network, but also allowing us to offload our operational stuff, to move a lot of cognitive functions which people do into a computer-based, software-driven world. Let's now start to look at the top, the AI piece. How can we imagine what AI intelligence will bring us in networks? It's difficult to predict this huge power of this emerging technology. I tried to show with this quite simplistic picture here. Might be me many years ago, born with just 1 gigabyte of data. This more or less represents the amount of data from our DNA. That's just information we require to construct our bodies, our brains, brain more or less empty. Learning, I tell my kids all the time, learning is the key. This makes what we are, and this unfolds huge potential of creativity. Over our lives, we gather a lot of data, carrying around roughly 1 petabyte of data. And this allows us to do much, much more than the guy on the left hand ever could do. For example, build creative, huge, complex networks, stand in front of you and do such hopefully interesting presentations. This gives you some glimpse of what learning can do. In this case, to us, the same thing will happen with networks. Where are we today? Probably we are very much on the left-hand side. Very hardware, very, very physical driven. The intelligence is just coming. Are we challenged to be replaced by computers and intelligence? Just give you one figure. Our brains have a power consumption in the order of 25 watts. A very powerful, perhaps the most powerful computer today, Sunway in China, using 10 million cores, 15 megawatt of power, and is not coming close to the power of our brain. And obviously, it's not easily to move around. So I guess we are on the safe side for the next years, but yeah, we'll see. So what to do with artificial intelligence? That's outcome from an TM Forum report which came out end of last year. It's highlighting the views from vendors. Those are the areas they are focusing on, and this is very much in line with what we are doing. Network optimization is one area. We, for example, have a project where we look at solving complex network planning, which you so far do with quite complex analytical models, solving Maxwell equations if you do a fiber-based network. We do this with AI. We are comparing how can you easily do it by just having a learning algorithm, educate them with a lot of tests, and we find out it's working pretty well and makes planning much simpler. Just one area, fraud detection, pretty sure network security, identify advanced persistent threat attacks, quite complex thing. AI will help a lot there. Personalization, chatbots. In the same report, there was a note that today, roughly 30% of service providers apply chatbots for customer care purposes, for example. 60% said, okay, we do that, but we have some person sitting next to it, and if something goes wrong, he immediately can step in. With this, I would like to come to my next point. Some ways how artificial intelligence can be applied. The typical method is, initially, you need data. You need a lot of data. It's shown here in this kind of sheet, features, which describe some behavior, performance value, whatsoever, and some outcome. Let's take a very, very simplistic example. Again, network security. If there is a lot of failed login attempts, and those login attempts come at 3 o'clock at night, and they come from a quite strange place, then you might be in a situation where someone is trying to attack your network. Very, very simplistically. And if you have a database where you gather those input data, remote, at night, failed attempts, and you identified this have been attacks, then an analytical method might identify and help you to derive this rule, as just said, if at night, late, remote, failed, this is a failure. This is, in simplistic words, what data analytics can do for you. The good thing, and this is why the guy on the right-hand side is smiling, you easily understand the mechanism. This analytics provide you with a rule. You look at the rule, you look at the data, and you know the rule is right. You can confidently apply it in the future. It's a tool for you which efficiently works. This is one way of using AI. Another way, which is much more powerful, is with deep learning. How is deep learning working? In this case, you have a neural network. The neural network is processing this training data, and you, in supervised learning, you tell it, okay, with this set of input data, we have seen this kind of output. The neural network has various layers which build a kind of abstraction of the real situation. Those abstractions are their parameters in this neural network, but they are for a human not comprehensible anymore. So after you have trained the network, that's shown on the right-hand side, you have a very powerful tool now, which allows you for a set of input data come out with an output. This might be the answer, you are under attack. But in this case, it's a black box. You cannot see in it anymore, and this is why this guy is not so comfortable anymore. The verification will be one of the key challenging questions of applying deep learning and this way of artificial intelligence in our networks. That's one reason why he is a little bit concerned. The other is, this really means that you move a function which a human did into a computer. You really offload him, he will get new functions. He needs to make sure that the input data is correct. If something is wrong there, garbage in, garbage out, you have a problem. So the roles will change. It's a very significant change process. Our lesson learned from that is, first, we shouldn't apply intelligence or automation on a complex, difficult to manage, inefficient system. Step one is make a network very efficient by structure it well, make it simple. I come back to that point. Verification, second thing. Initially, until confidence is there, develop tools which go in parallel with deep learning mechanisms and algorithms and help the operator to gain confidence. Security, I will not cover in this one, but this, again, the third very hot, interesting, and relevant topic. As you move people away, you lose a very significant piece of the overall system, which is creating assurance that nothing goes wrong, also prevents from attacks. You need to add security capabilities if you do automation and artificial intelligence. Bill Gates concluded the same thing. He's frequently quoted with this statement. So automation applied on inefficient solutions magnifies inefficiency. We completely agree on that one. Automation on efficiency magnifies efficiency. That's, I think, the first step we need to take to make value from automation and finally from autonomous systems. And that's, I now bring two use cases where we take action to simplify. Advice very much in disaggregation of networks. So we believe in the power of having modular, very well-defined, standardized components in networks. Next question then is how to aggregate those disaggregated components. Software-defined networking is the solution, the technology for doing that. If you want to visit us at our booth, we show a case done with a Telia company with another vendor where we show that you, in this case, can, in a fully automated way, provision optical paths over an analog photonic system. So this is the difference. Is so far, optical paths have seen as digital line, and the optical parameters have been developed and calculated in upfront. We look into the analog character of the optical transmission system, disclose all these parameters to a central controller, which has all information for doing path calculation in the photonic domain, end-to-end, even over vendor domains. And that's a very, very, I can't think, a powerful way of simplifying networks through open interfaces, horizontally as well as vertically. If you want to hear more about that, visit us at our booth. This is simplifying the operation, simplifying the activation. This is with zero-touch provisioning. So we at ADVA, we are delivering roughly 200,000 demarcation devices per year. So far, most of them are manually activated. Here, a mixture of automation using netconf and Young modeling, but using very sophisticated, standardized security processes. This is our zero-touch provisioning implementation, and this allows our customer service providers to ship our devices directly to the end customer. They don't need to be touched by the service providers anymore. They activate themselves in a very secure way. They upload their configuration, they update the software, firmware, they pre-test in a fully automated way and activate services in an automated way. So this is the simplification on the provisioning piece. That's things which can be done today. As I said initially, first step towards automation and autonomous networking. Now let's come to two low-hanging fruits for machine learning and artificial intelligence. This is predictive maintenance. A service provider's network has thousands, 10,000, 100,000 of components. Those components can fail. On the right-hand third, there's a right-hand curve. There's a typical life cycle of a component, initially performing well over lifetime, deteriorating, reaching values which might have some impact until it fails at the end. Today, frequently networks are operated, you wait for the failure and react then. What can be done differently? You analyze a lot of data from your network. This is performance data, temperature of components, all kind of data, and use it to feed into a neural network, into an intelligent algorithm, which helps you to identify this component is at risk. It might fail within the next 2 weeks. Learned from historical failures. We implemented that, worked together with various of our customers, and identified really very, very powerful results from that. For specific failure scenarios, we can identify outages in our area of 2 weeks before they happen. That's shown on the right-hand side. There's a failure curve of thousands of connections, performance measured. We identified failing links, indicated it to the service provider who could have taken action. Action has not been taken in this case, and roughly 3 weeks later, those links have failed. So we can prove that the model is working. The benefit clearly, if you know that something will fail, you, for example, wouldn't provision a critical link over it. You can take action, for example, during daytime, securely offload all traffic. So from an operational perspective, easier to handle problems, minimizing impact of problems in your network. Just two of our artificial intelligence use cases, many others are under research or in early discussion with customers for application in the network. A final one shown here, virtual CPE use case, NFV at the edge. In the past, we had proprietary network element at the edge. From a security perspective, security by obscurity. As we go for NFV, we open up, which significantly increases the attack surface of your network. So you need to counter it. Again, here we do it with AI. Shown here is a server, virtual switch software running on that, 2 applications, a virtual firewall, but a virtual bot made it into it already. How do you identify it? One way, and this is what we do with artificial intelligence, is measuring a lot of information or gathering a lot of information about what's going on in the virtual CPE on the server, partly by extracting data from the CPU itself. So Intel, for example, provides you with a rich set of information, data from the SSD, smart data, for example. We added external capabilities to monitor what's going on a server. And if we use all that data and use it to learn an intelligent algorithm, we found out that you can make the mechanism reasons about what's going on and is identifying critical attack situations. With this, I'm at the end of my short presentation, making a move to autonomous networking. Talked about initial steps we should do and highlighted what solutions, with some examples, what solutions might be possible with artificial intelligence. Thanks a lot.
Thank you.